Quick question. How many letters are there in the alphabet? That's easy. 26. And what's beyond that? Nothing. Or is there? What comes after Z? What if it's AA? Then there's AB, then there's AC, then there's AD, all the way up until AZ, and then what comes after that? BA. And it continues all the way up until ZZ. So then what comes after that? AAA. So what if it kept going forever? What if it continued operating like numbers? Well, let's dive in. Over 2 years ago, I made a scratch game where you move through letters in an infinite alphabet like the one I showed to you earlier. And it goes from A all the way up to Z, 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 Z. A huge letter, but what comes after that? Around that same period, I made a video, which I re-uploaded from the Chrysoperifront, that counted letters all the way up to absolute infinity, but I would like a more proper and specific count. But first off, let's get into the letter groups. So 26 letters are equal to one alphabet. 26 alphabets are equal to one betagam. 26 betagams are equal to one gamma delt. 26 gamma delts are equal to one litarion. 456,976 litarions is equal to one bislitarion. And 456,976 bislitarions is equal to one trislitarion. So yeah, 456,976 is 26 to the 4th, by the way. By the way, you can also put a space every 4 letters, just like how you can put a comma every 3 numbers in numbers. So now we need to find a way to indicate large letters without taking too much space. In my letters from A to absolute infinity video, I would indicate A, which is A 9 times with A times 9, but I'd like to use a more mathematical form. Well, I think the best we can do is try to count all the letter groups and use them. So, for example, instead of saying ZZZZ, 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 we can just say trislitarian ZZZZ. So now we have to count beyond the trislitarians, which, as we said earlier, come every 26 to the 4th of the previous letter group. So after trislitarians we have quadrislitarians, then quintislitarians, sextislitarians, septislitarians, octislitarians, nonislitarians, decislitarians, and we continue counting them with the number prefixes followed by the suffix litarian. So now we've kind of found a way to keep counting up. Now let's count down. So for this, we'll obviously use the negative system to count below A, but we'll need a neutral letter that divides positive and negative letters, like 0 in numbers, and we don't have one. So we're going to use the null symbol indicated on the screen to represent the letter equivalent of 0 and call it null. So for example, null G is like saying G, just like how 06 is like saying 6. However, A null does not precede AA, unlike how 10 precedes 11. So before A comes null, then negative A, negative B, negative C, negative D, and it continues just like when we count upward, but of course with the minus in front of it. And there you have it. We now have a letter system that operates just like numbers, with no beginning and no end, and with the midway point being null. But we're not done yet. Now we're going to see to what number each letter corresponds to. So for example, if Z is the 26th letter, then AA is obviously the 27th letter, and AZ is the 52nd letter. BZ is the 78th, and CZ is the 104th. Anyways, we know that Z is the 26th letter, but what about ZZ? Well, we have to multiply 26, the number of letters in each alphabet, by 27, the number of alphabets in a betagam, plus the null alphabet from A to Z, which is 702, so ZZ is the 702nd letter. To find the corresponding number of ZZZ, we have to take 702, the number of ZZ, and multiply it by 27 again, which gives us 18,954. So ZZZ is the 18,954th letter. If we multiply that by 27 again, we get the corresponding number of ZZZZ, which is 511,758, and so on. So multiplying by 27 will add a Z digit to the letter every time. So here's the corresponding number of every letter that has all Z's up until ZZZZZZZ. Now we're going to do the same, but in the opposite way. We're now going to try to find the corresponding letter of every round number. So we can easily tell that the corresponding letter of 1 is A and that of 10 is J. But what about the others? Let's find the corresponding letter of 100. So we know that CZ is the 104th letter. So to find the 100th, we just have to go back 4 letters and we get the letter. So the 100th letter is CV. But now, finding the corresponding letters of higher round numbers is pretty long. You have to find the corresponding letter of the number right after the round numbers out of the ones you have. Then, subtract betagams, alphabets, and finally letters to find the corresponding letter. Here are all the corresponding letters of the round numbers on screen up until 100,000 because I was too tired to do higher numbers. And that's all there is to say about the infinite alphabet. Now, about a week ago, I actually made a variation of our infinite alphabet game, but with Greek letters instead, where it goes from alpha all the way up to omega, 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 with the same system as the English alphabet. So there you have it. So as we can see, just like numbers, the alphabet can have no beginning and no end. Thanks for watching, and I'll see you all next time, folks.